Okay, so last week, although a lot of you were not present, we are looking at errors and the ways of quantifying my errors. And we defined what an error is. We said an error is just a noise in a measurement, the uncertainties which we found in measurement. And also we said that no any measurement is accurate. Every measurement has an associated kind of error which needs to be quantified. But then when you quantify your error should be within the acceptable range of 5%, which can be -5% or +5%. And this is illustrated by this figure. That's errors beyond this range are not acceptable. What you need are errors within the range of 5%. Then we went on to look at absolute errors. We define absolute errors as the difference between the true value and the measured value of a quantity. And we said the true value is just the average of measurements which you are taking. When you are doing each and every experiment, in class we said that when taking my measurements, you need to take 2 or more measurements, and basically 5 measurements are okay. And you do the average of the measurements. The average value or the mean of the 5 measurements which you get, it's what we are calling it as a true value. For example, if you take a measurement which is A1, A2, A3, and up to AN, and we suppose that person number 1 has taken measurement A1, person number 2 has taken measurement A2, person number 3 has taken measurement A3, up to infinity. Then the arithmetic mean of all these measurements is what is called as the true value and is symbolized as AM. And mathematically, we are saying the true value, which is AM, is equal to the summation of all the measurements divided by the number of measurements which you have taken, which is the same as the mean of the measurements. Then to find the absolute error in the measurement, we said the absolute error color for each and every measurement. For example, for A1, you find absolute. For A2, Muzabe is also absolute up to AN. For example, the absolute error in A1 is the true measurement, which is a true value, minus that particular kind of measurements which you have taken, which is A1. And for A2, the absolute error, it will be the true value minus the measurement which you have taken as A2. And similarly for AN up to the end. So these are the absolute errors. Then we want on to look at the mean absolute errors. And by mean absolute errors, we defined the mean absolute error as the magnitude of absolute errors in the measurements. The arithmetic mean of the magnitudes of absolute errors in the measurements. And we said now good all absolute errors amene mwapeza under the last slide amene akhala in a positive form mukamapeza the mean absolute error. So you take the abscissa value of all the absolute errors divided by the number of observation. So it's like the mean of absolute errors, the mean of positive numbers of absolute errors. So what you get is the mean absolute error. So if you read most scientific papers, we say you find that they are written as 4.6 plus or minus 0.6. So this plus or minus 0.6 is an indicative of an error. It means you can go up by 0.6 or you can go below by 0.6. That's the meaning of putting a positive or minus 0.6. Then we also looked at relative errors, and we said relative error is the ratio of mean absolute errors to the true value. The ratio of the mean absolute error to the true value. From the last slide, timabeza the mean absolute error, and we said the mean absolute error, the mean of all absolute errors. Mupanga sum absolute errors in the positive value ndiweza mean yake. Then that mean of absolute errors divided by true value ndimeti kucha kuti it's a relative error. I don't know if it's clear or not. Then lastly, we have the percentage error. The percentage error is just the relative error expressed as a percentage. The relative error expressed as a percentage. That's the percentage error. For example, let's say that five measurements were taken, and these 5 measurements are 2, 3, 4, 2, 3, let's say 1, then you have another 3, and lastly another a 4. So these are the measurements which I've taken. The first step in calculating my errors, if you want to relate the error, you have to start with absolute. So absolute, you add all the numbers. First of all, add all the numbers. 2 plus 3 plus 1 plus 3 plus 4. Then you divide by the number of observation, which is 5. What you'll be getting, this will be the true value. So what you'll be getting here, it will be the true value. Then if you do correct real addition, 2 plus 3, it's a 5. 5 plus 1 is 6. 6 plus 4 is 10, and 10 plus 3 is 13. So 13 divided by 5, you get 2.6. So 2.6 is our true value. So we're saying the absolute errors, will be, so I'll go to the next slide. Absolute errors will be for measurement. So I'll just copy this so that we should see it on the next slide. The absolute errors will be for measurement 1. Let's take this measurement 1 is A1. The absolute error, it will be the measurement of 1, which is 2, minus it will be the true value, which is 2.6, minus the measurement of 1, and what we get, it will be 0.6. So this is absolute error for measurement number 1. For measurement number 2, the absolute error, it will be the same true value, which is 2.6 minus now 3, and what we are getting here, it will be negative 0.3. So 2.6 minus 3, minus 2 is 0.6, then 2.6 minus 3. Okay, you'll be getting negative 0.4 as an absolute error. For measurement A3, the absolute error will be the same true value minus now measurement yake, which is 1, and what we'll be getting is 1.6. That's positive 1.6. Okay, I should indicate the positive. Then for A4, the absolute error will be the same 2.6 minus 3, and you get negative 0.4. And for measurement number 5, the absolute error, it will be 2.6 minus 4, and what you get is 2.6 minus 4, you get 1.4, positive 1. Negative 1.4. So these numbers which we have written here, these numbers are what we are calling them as absolute errors. Now, to find the mean absolute error, I'll copy all these numbers so that we should see them in the next slide. The mean absolute error, we will take these absolute errors, but now in their positive form. So mean absolute error, it will be all these absolute errors: 0.6 plus 0.4 plus 1.6 plus 1.6 plus 0.4 plus 1.4. All these numbers divided by number of entries, which is 1, 2, 3, 4, 5. So I think you don't regard the sign. You take all numbers as positive when you are finding the mean absolute error. So when you add all these numbers, 0.6 plus 0.4, it will be 1. 1.6 plus 1.4 is 3. 3 plus 1 is 4. Then 4 plus 1.6, you get 5.6. So 5.6 divided by 5. 5.6 5.4. Okay, 0.6 plus 0.4 plus 1.6 plus 0.4 plus 1.4. .4 plus 1.4. So you are getting 4.4. 0.6 plus 0.4 plus 1.6 plus 0.4 plus 1.4. So you are getting 4.4, and this 4.4 divided by 5. So what you are getting as a value is 0.88. So this is 0.88. You add now a sign which is positive or minus. So you add a positive or minus sign to indicate that is an error, and the error of a true measurement, and that true measurement is 2.6. So the mean absolute error of all these values which have taken the 5 measurements, the mean absolute error, it will be 2.6 plus or minus 0.88. It means that mutagubira mwamba ndi 0.88, or you can go down the 0.88. So that's how you find the mean absolute error. Then after finding the mean absolute error, you need to find the relative error. So I'll go to the next slide to illustrate how you find the relative error. So by formula, the relative error, we are saying it's the ratio of the mean absolute error to its true value. The ratio of mean absolute error to its true value. So from here, you see that the mean absolute error in our measurement, it was 2.6 plus or minus 0.88. Now the relative error, it will be 0.88, which is our mean absolute error, divided by our true value, which is 2.6. So what you are getting here is the relative error. So when you divide that one, 0.88 divided by 2.6, you are getting 0.338. So this number which you are getting now is what we are calling it as the relative error. Percentage error. Percentage error is just the relative error which you have found here, 0.338, multiplied by 100%. and what you are getting after multiplying the 100 is 33%, and this is an error which we are calling it as a percentage error. I don't know if it's clear on how we calculate the errors. Otherwise, we may continue with our lesson on error propagation.